Kia ora and welcome to this video that goes through question 3a of last year's Probability Concepts Level 3 paper. I'm going to try and keep this video quite short, so question 3b will be done in a separate YouTube clip. Just wanted to say as well that the assessment schedule is not out yet from NZQA, so these are my answers. They may not be completely correct. The marking panel might have had some other ideas, and that's especially the case for the last question in this video. So this question is all about people taking their cars for warrant of fitness checks, and this is looking at a case with 3 testing centres. Testing centre A, B and C. Over 1 month, all of the tests that were done were recorded by each of the testing centres, and we're given the information about the percentage at each centre. So 40% were done at A, 25% at B, and so we must have 35% at C. Okay. Now we're given conditional probabilities next. So the probability that a car tested at A passed its warrant was 82%, and so on for B and C. Now, because we're given the information in the format of unconditional probability first, that's the centres probabilities, and then conditional on being done in a particular centre, it makes sense to do a tree. So we'll do that on the next slide. So my tree is going to have 3 branches, A, B and C, and then for each of those it will have pass, fail. And the first question is asking us what percentage of tests completed during the review was successful. So we'll put the probabilities on of being done at A, B or C. And then at test centre A, 82% passed, 0.18 failed, 0.96 for B, and 0.04, and 0.94 and 0.06. So the probability of passing is equal to 0.4 times 0.82 plus 0.25 times 0.96 plus 0.35 times 0.94. Right, or you might have written out the 6 different probabilities at the end of the tree branches, and that's fine too. Okay, so if you do that calculation, you'll find that it comes to 0.897. However, we are not asked for a decimal, we're asked for a percentage, so we need to change that into a percentage. So we need to give our answer as 89.7%. Right, so 89.7% of the tests done during the review were successful. Right, next question. Of the tests that were unsuccessful, what proportion were completed at testing centre C? So we're looking for a conditional probability. Given that a test was a failure, what are the chances it was done at C? Now, you can do this using your definition of conditional probability, pretty straightforward application of this rule. So the probability of A, given that B has happened, is the probability of both A and B happening, that's the numerator, divided by the probability that B happened. And this is the idea we saw back in year 12 of limiting the sample space to just those times when B happens. So in the case we've got here, the numerator will be the probability of C and fail, and the denominator will be the probability of failing. So the probability of C and failure is going to be 0.35 times 0.06. You can see that if you look back at the tree, divided by the probability of failing. Now we know that the probability of passing was 89.7, so the probability of failing is 1 minus that. which is 0.103. So we get this. So working that through gives me a probability of 203.883, which is, I would go with 20.4%. Again, that's to 1 decimal place. Now, there's a hint given in here that you may wish to assume that there were 10,000 tests completed during the review. And that's trying to encourage you to use a table to solve this problem. Now, you don't have to do that here, but it's a good method, especially if you're not completely confident with the conditional probability formula. So I'm going to do that on the next page. Right, so we'll set our table up. A, B, C, pass or fail. Right, so here I've got 10,000 tests, and I know that 40% were done at A, so that's 4,000, 25% at B, and 3,500 at C. I know that 82% of the tests done at A passed. So this number in here we can now calculate as 3280. Right, so that's 0.82 of 4,000, and so on. So at B we had, I think we had 96% at B, I just have to check that. Yeah, 96% at B, so this is going to be 2,400. And at C we had 94%. So 94%, 0.94 of 3,500. And that's going to equal 3290. So down here I'll have 100 because they have to add up to 2,500. And in this slot here I'm going to have 720. And in this slot here I'll have 210. So what I'm looking for my probability is, I'm just trying to find the right question, sorry about this. Where are we? Oh, we're looking to see the proportion that were unsuccessful. What proportion were done at C? So our unsuccessful, our fail line is, let's see, 1,030. Right, so these numbers might be starting to look familiar. So the probability of it being done at C, given that we failed, were 210 out of 1,030. Right, so it's the same, exactly the same answer as we get by using the formula. So that's 0.203 and that's 20.4% to 1 dp. Okay, so there's two different ways to answer that question. Okay, the last question in here is asking whether a car owner who's decided to go to test centre B to have a better chance of passing is justified in thinking that. So I think where I would start with this question is by saying, well, let's first look at the pass rates. So the probability of passing, given that you've gone to A, is 82% or 0.82. Probability of passing, given that you've gone to B, is 0.96, I think. Yep, that should be the high one. Yep. And the probability of passing, given that you've gone to C, is 0.94. Now, you didn't have very many lines here, but there's quite a bit that you could say. Overall, what you want to be saying is no, the decision is not justified based on the information we've got. What we've got is we've got estimates of the probability of cars passing at each of those testing centres. So I think the first point is that even if we did it again, so if we took another month, even if the types of cars and everything at those centres were similar to this month, we'd expect slightly different numbers. So slightly different pass-fail rates. right? And so that's enough reason not really to distinguish between B and C. B's rate is 96%, C's rate is 94%. Yeah, they're a little bit different, but it's hard to know. There were 3,500 cars in one, 2,500 in the other, right? So it's not hard to imagine that those two could flip over. But that's not the fundamental problem with what the car owner is trying to do here. And what it comes down to is that we don't have any information about the types of cars or the types of driving behaviour at the three different centres. So when we try and find a probability estimate, we're trying to estimate the true probability, okay, of a car passing a warrant, right? So true probability depends on lots of factors. And the chances that this car owner's car passes at test centre B may well be exactly the same as if she takes her car to test centre A. So what might be going on? Well, we could have people who have very, very new cars, which are more likely to pass their warrant, living near test centre B, right? Test centre B could be in a really, really wealthy suburb. If the average car age is only 1 or 2 years old, you'd expect nearly all the cars to pass the warrant, regardless of where those cars are taken. And test centre A could be in an area where the average car age is much, much older, and people can't afford to buy new cars or to spend money maintaining them. So what that means is that given that you have a particular car, the probability that your car will pass may not be affected by where you take that. And the third factor in favour of that uses general knowledge about New Zealand is that the people who do the warrants have to follow very closely a set of rules about whether to pass or fail a car. And you would expect that they would be following the law about who gets a warrant pretty closely. So the fact that there are different pass rates in the centres shouldn't be reflecting leniency of vehicle inspectors. Okay, so the decision to go to centre B is not justified based on the facts. That will be really interesting to have a look at the assessment schedule for that question, and I definitely recommend that you do that between now and November when it comes out. Okay, that's all I'm going to do on this video, partly because my iPad battery is just about run out. Hope that helped, and let me know how you found it. Thanks very much.